Hello and welcome. We'll be going over how to create LogZilla Lua rules. Now, the files in this video are available on LogZilla's University GitHub repository. Anyway, for those unfamiliar, LogZilla is a network event orchestrator. What this means is that LogZilla watches information streams such as log files, it deduplicates filters and parses the log event messages, and it will react to those events in real time, from sending out email alerts up to and including automatically remediating problem conditions. Rules are one of the main features of LogZilla. Rules allow you to parse incoming log messages and extract or modify the log message information in order to make those log messages more useful to you. Most commonly, rules are used to do two things. First, to add to or change the log message itself. A common example is that many log messages contain a timestamp in the message text. Since LogZilla records its own timestamp information in a format that is more consistent and more useful, there is no reason to keep the timestamp in the message text. Not only is it redundant, it prevents message deduplication. So a rule can be used to alter the log message text by removing that unnecessary timestamp. The second common task rules perform is to create user tags. There is another video that is an introduction to user tags, so you might want to watch that video and come back, but we will be going into some detail regarding user tags in this video as well. Anyway, rules are used to extract information or data elements from the incoming log messages and then record those data elements under specific names called user tags. These specific data elements then can be used for searching, for filtering, and for display in widgets on dashboards. Now then, rules in LogZilla are small programs that tell LogZilla how to read and process the incoming log messages. These programs typically are between 30 and 100 lines long and follow a common format. The rules are written in the Lua programming language. This language is fairly simple and basic as programming languages go, so don't be intimidated. Rules have two parts, the Lua rule and the rules test. The Lua rule contains the instructions for LogZilla about what to actually do with the log message. The rules test is only used during rule creation, but it is very important in that it verifies that the rule is valid and that it does what you intend it to do. So let's dive into it. The first thing to do when creating a rule is to get samples of the log messages that LogZilla will be receiving. You will need to know exactly what LogZilla is seeing in those incoming log messages in order to tell LogZilla what to do with them. One thing to note is that when I say log messages, I mean the complete contents of the log message according to the syslog log format. The syslog log format is a specification that is used for the vast majority of log messages that are communicated from one system to another. Syslog specifies that each log message must contain additional information beyond just the text of the log message. Syslog log messages also must contain the originating host system of the log message, the program name that created the log message, the severity of the log event, the facility or broadly speaking the type or general classification of program that created the log event, and optionally a few other fields for message ID, process ID, encoding, and structured data, though those in particular are rarely helpful. So there is valuable information besides the log message text, and LogZilla reads and will save and display that information. If you look at event detail, here are some of the syslog fields as displayed by LogZilla. Severity, host, facility, program, and the message text. So why is this important? If the log message LogZilla is receiving is in fact a syslog log message, which is usually the case, those syslog fields are very helpful in interpreting what the log message means. When you are collecting samples of the log messages you want to handle, it is greatly preferred that you also gather details about what those syslog fields are going to be on those log messages, in addition to the plain message text. LogZilla rules can read and use those extra fields, and they are very helpful both for rule operation and for presenting the right information for LogZilla to handle. The next thing to do is to determine in detail what you want the rule to do. Now that you have samples of the log messages, you can plan out what to do with the information contained therein. As mentioned, the primary purposes of rules are to modify the log message text itself and to create user tags. When you plan out what you are going to do with the incoming log message, your plan should be to accomplish one or the other, or both. Let's look at an example. We'll use an Infoblox DNS service log example. In this example, we are in fact going to do both operations, namely alter the message text and set user tags. To reiterate, the best way to start is to begin with the actual log messages you will be receiving. Let's look at our example environment. Here you see log messages coming from an Infoblox device. These are basically Linux named service logs, which you may recognize. For our purposes, the two items of interest are the program field and the message text. You can see that we are also receiving values for the syslog fields, severity, facility, host, etc. But our rule doesn't need to know or change those. Here's a sample raw log message that we received from the Infoblox system. This is the message text, and you see here that we know for these log messages the syslog program field says name D. That's what we're starting with. I've copied the information over here for clarity. Since this shows what we're receiving and what we want to do with the log message, there are three things we want to do. 1. Change the program name from named to Infoblox. 2. Change the message text to remove the superfluous Infoblox responses text and remove the redundant date and time. And 3. Set some user tags with specific information from the events, such as source IP, query, query type, and response. I've put those desired results here for clarity as well. We've identified what the incoming log messages look like and what we want to do with them. We're ready for the next step. Now, as I've previously mentioned, when creating a rule, there are two parts: the rules test and the Lua rule itself. The rules test is how you verify both that the rule is valid as well as that it is going to do what you want it to do. Now that we have seen the incoming log message and know what we want to do with it, we can make the rules test. The rules test is a YAML file. YAML stands for YAML Ain't Markup Language, which, to be clear, is in fact recursively self-referential. So you heard that right. If you are familiar with JSON, YAML fills the same role in being a format and syntax for encompassing data. YAML doesn't look like JSON, though. YAML is delineated more strictly with spacing and line breaks, which makes most people think it's easier to read. In any case, the rules test file should be a YAML file. Here at the top of the test file, we put the test cases directive. This tells LogZilla that this YAML file is intended to be a rules test file. After that is a sequence of one or more specific tests. Each test has two parts: the event and the expect. The event describes what the incoming log message is going to look like. This will be the information that we saw in LogZilla and then recorded on our summary sheet. The expect tells LogZilla what you expect to have after the rule runs. Both the event and the expect, then, are subdivided into parts that mostly mirror the parts of a syslog message. In this current test, you can see that we are specifying the program and the message, which, if you'll remember, are the two parts we had mentioned earlier as being important to us. Here you could also put values for severity, facility, host, and more, but for this rule we're not using those. That's how we specify the program and the message that we want to use with the test. Next is the expect portion. Similarly to event, this portion is divided into syslog fields with the addition of specifying user tags. Remember, this is what we're going to have after the rule runs. In the case of our rule, we want to change the program name, we want to change the message text, and we want to make some user tags. In this particular expect, we need to describe what the program, message, and user tags are going to be after the rule runs. You see here under the word expect, it does specify the program, the message, and several user tags. Remember, this is what we're going to have after the rule runs. You can see the YAML syntax is easy to read, but there are some tricks like using the greater than minus. Specify the multi-line message, so you may want to read an introduction to YAML before making your own tests. Now we've finished the first test in our test file. We could stop there and go on, but more tests are better than fewer, because that will help ensure your rule is working properly. The general rule of thumb is that you don't need multiple tests to check the exact same logic, but if your Lua rule can do different things depending on what the incoming message looks like, then you should make tests for each possible input case. So for the second and subsequent tests, you just start a new event section, followed by its expect section. Just precede the word event with the minus here to indicate this is another individual test within the test file. That's it for the test file then. We know when we've told LogZilla what the rule is supposed to do. Let's make the rule to do that. Here's our rule file. The rule file is divided up into 4 parts. The first part is the Lua requires portion. This specifies which Lua libraries the rule needs. The Lua libraries are Lua modules that are provided for you to add optional functionality to your Lua rule. In this first example rule, we do not have any extra Lua libraries we need, so this section is empty. The second part of the rule is to specify the regular or LPEG expressions you are going to use. LPEG expressions are conceptually similar to regular expressions, if you are familiar with those. The quick description is that either LPEG or regular expressions are letter patterns or templates that are supposed to match given text and selectively parse fields from that text. We are using them here because we need to have a pattern to match what the incoming log message is going to look like, as we previously determined, and to extract from that log message the specific information we want for user tags, such as source IP, response, etc. In this first example rule, for simplicity, we will use regular expressions. LPEG expressions are greatly preferred over regular expressions because they perform much better. And since this expression runs for every single log message received, its performance is important. Regular expressions are, however, supported, and this first rule uses them. So the second part of the rule specifies the regular expression that we are using. I won't be explaining the concepts of regular expressions here, but I'll quickly indicate what the one we are using here is doing. You'll see that the first line here makes the regular expression look for the words info blocks responses, followed by the date and time field. Then the next line is where we start capturing information, because it expects the word client followed by some numbers for the IP address. The third line gets the remaining fields, namely the IP port, the DNS query type, and the response, along with some interstitial fields. In this rule, we are just using that one regular expression. So on to the next section of the rule. Next is the process function. The process function is absolutely required. This is the logic that runs for every log message received. This function is what examines and parses the incoming log messages one by one, and then alters the program, message, etc., as desired and creates the user tags. This is where the actual work of the rule happens. You use this line exactly as written here, function, process, event. This is a Lua function definition starting a Lua function named dProcess that takes one parameter, event. Then comes the body of the process function, and this body part is going to be different from one rule to the next. In general, though, the first thing to do is check as much as possible if this particular log message is one that this rule should be processing. You should note that every single Lua rule will run for every single log message. Therefore, it is critically important that as soon as possible you try to determine if this log message is one that this rule applies to. In this case, we know that all the info blocks DNS log messages have a syslog program field with value name D. First, we check that because we only want the rest of the rule to run if that is true. We've determined that the program name matches, so we are fairly certain this log message is for this rule. We can proceed. Next is to take our regular expression and try to match it to the log message. With this rule, we are trying to use specific data, so we use the regular expression to verify that data is in the log message, and to parse that data from the log message. Local is used to declare a Lua variable named match. That variable is set to the results of running the rex.match function. For rex.match, we are using two parameters, the first of which is event.message, which is the event message text. Your rule will almost always use event.message. Event.message means the message field of the event data object. The event data object is what is coming in when LogZilla calls our process function. The event data object has several fields that you use for input and output of the log messages and user tags. In this case, we are trying to match the event message to our regular expression that we defined earlier, and if it matches, then the results go into the Lua variable named match. Next, we check to see if the regular expression did match, because we can only continue if it did. Now you'll notice that we are assigning values to fields of the event data object. First, we change the program name to info blocks by setting the program field of the event data object, event.program. Then we start setting user tags. You see that for user tags you do event.usertags, then in square brackets and double quotes the user tag name. On this line we are setting the user tag source IP to match1. Match1 is the first value in the match variable. You recall that the match variable contains the results of our regular expression match, so match1 is the first match in that regular expression. The next line sets user tags query, query type, and response to other fields matched from our regular expression. Last, you see that we are setting the event.message field. This is changing the actual log message text. You remember that we wanted to remove the info block's responses text and the superfluous state in time. Well, our regular expression ignored those bits, it didn't capture them. We can just rebuild the event.message text with the parts that our regular expression did capture. You can see that we're rebuilding that message text one match capture at a time. In Lua, the double periods mean concatenate the text. We take the word client and add on match 1 and a pound sign, then match 2 and a colon space, and keep going with match 3, 4, 5, etc. The next few lines just close out our if blocks from above. That's it for the actual rule of function, the rule of logic. Section 4, the last section of the rule here, is setting HC tags. HC tags are high cardinality tags. High cardinality means that the user tag can have very many different values. LogZilla by default will index your user tags so that they can be searched and filtered quickly. However, indexing user tags that have very many values will cause LogZilla to perform poorly. So you should use the high cardinality indicator on such user tags to tell LogZilla not to index those values. Finally, a good rule of thumb is if there are more than 40 or 50 possible values for a user tag, you should set it to high cardinality. In the case of these DNS log messages, we'll assume this is a larger organization and there may be more than 50 source IPs for the queries, and then the user tag for the DNS query itself will likely have more than 50 values as well. So we use this syntax to set a Lua variable named C tags to contain these two user tag names, source IP and query. The variable can hold as many user tag names as are appropriate for this rule, whether that be 1 or 10 or whichever. Although it is rare to have 0 tags that should be high cardinality, if that is the case for your rule, then you can omit this section entirely and leave out the HC tags. So at this point we have our test file which describes the incoming log messages and what we want to do with them, and we have the Lua rule file that has the logic to actually make that happen. We are ready to load it into LogZilla. To load the rules file, you should have the Lua rule file and the YAML test file together in the same directory. Then you use the LogZilla rules add command to add the new rule to LogZilla. In this case, everything is correct, so LogZilla tells us the rule is loaded. You can do LogZilla rules list. And you see here is our rule name indicating that it is a Lua rule, and that since everything is correct, the rule is enabled. We'll remove that rule now. There's much more to cover, but we'll stop here for this video. There are more videos in this series that I encourage you to watch. These include topics such as how to use LPEG expressions instead of regular expressions, what additional functionality LogZilla provides for you to use in rules, such as GeoIP lookup, how to debug problems with rules. That's it for the basic instructions for LogZilla Lua rules. Please feel free to watch the remaining videos in the series. If you have any questions or for more information, please contact us at our website, logzilla.net. Thanks for watching.